So before we get into kind of all the fun things of combinations and permutations and probabilities, we want to kind of first remind ourselves, and this is not a trivial aspect to this course. We actually, counting can be very difficult, to be honest. And especially as we go through these different types of combinations or permutations, we really want to have kind of a physical model in our head about how we can put equations that are often abstract and can be difficult to interpret into something that's a little bit more tangible. So let's go ahead and get started with that. So right now we're trying to figure out, again, given a certain number of choices, what are the number of possibilities that we can observe for a given scenario or a given kind of parameter space. So let's invoke one of the kind of a statistical theorem. So if I have a certain number of sets which contain a certain number n of elements, I can multiply the number of those elements for each of those sets, of choosing a1, a2, to figure out the number of possibilities. So let's look at an example. So I'm trying to maximize the yield of a field where I'm planting lettuce. So I have 2 fertilizer options. I have 4 blocks to plant and 3 types of seeding densities. You're going to see this in the ANOVA analysis later on in the lecture, in the class. But so remember this example. So how many possibilities of planting combinations can we observe? So what are our sets? Well, we have fertilizer, we have basically our blocks, and we have seeding density. And for the fertilizer, our n is equal to 2. For blocks, 4. For seeding density, we have 3. So we can multiply that out, and we get a result. Another possible example is, okay, I have a true-false exam. So I'd never give full true-false with 15 questions. So how many combinations of that can we observe? Well, again, what are my sets? I have question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 15. And what are our possible, answers? It's true or false, 2. So I can do 2 to the 15 and get that for my number of possibilities. And that's why you don't want to grade that. But let's try to visualize this, because I think it's kind of important. So let's say that we are working with a system now where I have basically 3 rounds where I can choose essentially basically between marbles. So let's try to visualize this a bit with an example. So let's say I have 3 rounds and I want to select from, in each of those 3 rounds, I have 2 options. I'm going to either select, I'm going to select a red ball or a blue ball. So sets, so 3 rounds, how many times? So 2 times 2 times 2, that should be equal to 8. So we should have 8, basically possibilities that can occur in this type of scenario. So let's go for the first round. So in the first round, I can either choose red or I can choose blue. First round, 2 options, right? Good, stay with me. Second round, I can be from that outcome or that possibility or that single possibility, I can choose red or blue. And if I was here, red or blue. So after the second round, how many possibilities are possible now? You can count them here. 1, 2, 3, 4. 2 rounds. 2 times 2 is 4. Let's keep going. Each of these are going to give me a red and a blue. They're going to give me red and a blue. They're going to give me red and a blue. They're going to give me red and a blue. After my third round, a red and a blue. 1, 2, 3, 4, 5, 6, 7, 8. So you can visualize and kind of see 3 rounds. What are the possible, what are the possibilities here? The possible arrangements that we can observe and visualize. So you can see we match here what we did here. And it's just a visual way of looking at those. So next time we are going to get into permutations, which is a very important concept. I'm just changing my pen here back to my red, and we'll get moving. See you next time.